Cool. Hey, everybody. So yeah, I kind of introduced myself yesterday, but just for everyone that might not know me, I'm Dustin. I'm one of the PSF directors. I work on PyPI a lot. I'm not a core developer. I also work on Google's open source security team, and I want to just tell you about that for a second because we call our team Ghost. This is a team that helped fund these sprints. So, and I was also like supporting. Thanks. Not entirely like Thomas's and GPS's team. Also, we split it, but Ghost also like supports all of my work on Python and PyPI and everything else. So I want to give you a little highlight of what we do because it sort of influences what I'm about to talk about. So in a nutshell, we focus on a couple different things. One is on supply chain integrity. So I also like name drop some projects that we work on, which might sound familiar. That's mostly Route 6 store. We work on software supply chain security, which is Salsa. We have a team that does vulnerability management, remediation, fuzzing, vulnerability discovering. So that's OSS fuzz, cluster fuzz, all those projects as well. Yeah, sorry about the slides. What was I saying? Ghost team does fuzzing, Linux kernel stuff. We have a whole team that works on the kernel self-protection project. We're also involved in some policy stuff. So we work with US government and White House on a couple stuff that's related to open source software security, new policies. I'll talk a little bit about that. We do a lot of funding. So sos.dev is the way that we fund sort of individual contributors to make security improvements. And slides are going to be pretty important. Yeah, we do funding. We funded some other stuff. We funded the CPython developer in residence program too. So that's for the first year. Second year is a different funder. And the summit. We work with a lot of organizations via the Open Source Security Foundation, which you might have heard of. Okay, online should be able to hear me now. Yes, okay, thanks. Yeah, so that's my team in a nutshell and sort of like why I'm going to be interested in all this work. So this talk specifically is going to be just about CPython. So we work on a lot of stuff. There's a lot of PyPI work that goes into all of that. But I'm just condensing everything that is going to be directly applicable to CPython. Basically the release and the build process and some other related stuff. I'm not going to propose any changes to like how Python itself works either, but maybe we could also potentially chat about stuff there too in the future. But I'm going to be here today and tomorrow too, so I'm also happy to talk about open source security stuff, PyPI stuff, like anything, packaging, anything you want to talk about. So quick outline. I'm going to talk about signing integrity for CPython, secure public builds, SBOMs, the PSF as a CNA, the PSF security developer in residence role, and what I need from you with some Q&A at the end. So let's start with signing integrity. Someone should probably mute over there. So yeah, if you go to python.org/downloads, you see this list, and there's a bunch of great stuff in here. Who would actually verify these things, right? Like, I know that you're probably all building from source, but how would you actually verify the integrity of these files, these artifacts on python.org if you wanted to? We got MD5 sums, cool, and we have GPG signatures. So, like, are we good here? Is this all that we need? So first of all, and I literally just noticed that we had the MD5 sums there. MD5, like what year is it? MD5 is definitely broken. MD5 is like a broken record that people just keep playing. So we probably should get rid of the MD5 sums on python.org. The other thing is like PGP is also kind of broken, like not in the same way, not in a way that like the signatures are invalid or could be invalid, but just that it kind of just doesn't work for users. There's lots of examples of this. People just sort of saying like, PGP Web of Trust doesn't work. The UX is not good enough. And whenever I talk about signing in the Python community, I have to talk about this post from Donald Stuft on the topic that's from 2013, which predates all those other articles about why PGP is not great. And what Donald was actually saying in this article, which I suggest you read, is not that PGP itself is bad, but it is that PGP itself is bad, not the cryptographic signing part. We want cryptographic signing. We want to be able to verify the integrity of those files, but just not with PGP potentially. So why? I'll try and summarize the kind of like two big issues with PGP. One is that establishing trust in a key identity is really hard with PGP. So for example, Pablo is the release manager. Which of these is Pablo's key ID?
know mine.
Yeah, do you? Okay, yeah. So neither of these are Pablo's. One is Lukash's and the other is Steve's. And I was going to be like, do you even recognize yours? Because like I feel like most people wouldn't recognize their key ID, but great. So this is why we put these key IDs up on python.org when we make releases. But what if python.org gets compromised? Like it's just a Django website. Someone could put a different key ID up there and someone could go and do the verification process that they're used to doing and they don't remember, they don't recognize Lukash's key ID or Pablo's. So what happens there, like if the key IDs get compromised? The other kind of big problem with GPG is that it requires humans to not be humans. So humans lose things. Humans even can lose their PGP private keys. I was hanging out with Paul Kerr one time and he said, GPG would be really great if we could go around stapling everyone's private key to their foreheads. They would never lose them, but that wouldn't be very nice to the release managers. It also wouldn't be super secure, right? It'd be on their foreheads. So what should we do instead? So you might have noticed that yeah, maybe like in a private place, you could staple your key ID or your private key. So you might have noticed that in the recent patch releases and in the 3.11 RC2, there's something new here on python.org. And this is some additional verification materials for signing and integrity. And this is the verification materials from a signing event with Sigstore. So I'm just kind of curious, like who's heard about Sigstore? Okay, so I'm going to give like a very high level overview of how Sigstore works and how it's a little bit different than what you might be used to with signing with PGP. I can go into much more detail about this if people are really interested. But I'm going to just sort of describe why it's better and why we're trying to move towards it and why a lot of other organizations are too. Yeah, Sigstore is sigstore.dev. So here's how regular signing with PGP works, right? At some point in time, you do a key generation process, and that gives you a public key and private key. And you probably did this like years ago. When we go to, and this is not just specific to CPython, but like any artifact that we're creating and signing, there's a build process that produces an artifact. Then we do a signing event that takes in the artifact and a private key. Then that produces a signature. And then when we go to actually like publish this for consumers to consume, we take the artifact, we take the public key, and we take the signature, and we make those available to the end users. So kind of the problems here, one is like the public key, where do we publish this, right? Publish the key IDs on python.org, and then you have to go and figure out where the actual public key is. And like for Pablo, it's on Keybase, and that's like a cryptography company or a cryptocurrency company now, I guess. The other thing is the private key, like do not lose your private key. There's all sorts of problems here if that goes away. So that's signing with GPG. There's really long-lived key pairs that are generated once, and they're reused for every release. Public keys have to be published somewhere, maybe with the artifact, which is okay. But you also don't really have a good way to know if your key's been compromised. If someone has signed something with your private key because they've acquired it in some way, and you just don't know, and maybe they're like distributing something saying that they signed it as you, there's no way for you to know. So this is what signing with Sigstore looks like. So first we start with the build. Notice we don't start with key generation. There is no public-private key pair at this point. We build an artifact, same as before. Then there's the signing process. And this all happens within the like command invocation that you do to sign the artifact, but there's a couple steps here. So one is that you generate an identity. And this identity, I'll say that it's an OIDC token. If you don't know what that means, let's just assume that this is something that uniquely identifies you, or potentially uniquely identifies some service, something that's running on the internet somewhere. This is built on top of OAuth 2. It's a standard. It's quite nice, and it's also verifiable. So these are usually tied to like email identities, but can be other things. I'll talk about that. Then you generate a key. So this happens per signing event. You generate a public-private key pair. You then take three things: the artifact, or actually the hash of the artifact, this identity, and this public key that you just generated, and you make a certificate request or certificate authority. And this gives you a certificate that essentially binds all three of those things together. It says, for this artifact, this person had this public key available in this short window of time, and this artifact or this certificate proves that that happened. Then you actually do the like regular cryptographic thing where you sign it, you take the private key and the artifact, generate a signature, and then when you publish the artifact as before, you publish the signature as before, but instead of having to worry about public keys or anything like that, you have this certificate. And the really nice thing here is, first, The identity and the public key are included in the certificate when that gets published. So it has all that information about who requested it and what the public key is for verification. The private key never leaves memory. You never see it. It never gets written to disk. It never goes anywhere. It's just like exists. We call it ephemeral keys because it's just there for a second. And then the last thing is that the certificate has to be published in a transparency log. In order for verification to succeed, when you sign, you have to publish that certificate saying, I, at this point in time, signed this artifact with this identity, with this public key. And when users want to verify this, they have to verify that that certificate existed in the transparency log, because otherwise there's no way to know if someone's been stolen your key in some way and done something like that. The other nice thing here is that you can then monitor the transparency log and see if anyone signed anything with your identity. And as soon as something happens that, which is something that we're not doing right now, but we will be doing for the Python releases for the release managers, as soon as you see an event that happens that you didn't, personally do, you know that something has gone wrong. Someone's been able to compromise an identity provider or something like that. So to recap, with Sigstore, the keys are ephemeral. They're generated once per event, never leaves memory. These identities are published with the artifact, and they are usually something that looks like an email address. And the signature is only valid if the event's been published in the transparency log. So this makes verification a little bit nicer. So first of all, we have like the whole point of all this is that users can do verification, right? So we've built a Python version of the Sigstore client, but there are versions for all these different language ecosystems and in different flavors as well. And the verification is very simple. You take in all these these verification materials, the certificate, signature, and the artifact itself, and then you verify that the identity in the certificate, in this case it's an email, is the email of the release manager, and that's it. You don't have to worry about interpreting, finding key IDs. Like, we know who the release manager is for this version of Python. We can publish those. Again, and also this is an identity that's on python.org. Like, it's going to feel weird to a user to verify this if it's not a @python.org email, right? So it provides a slightly better level of trust that this is actually an identity that's allowed and should be trusted to sign this, that this means something when the signature happens. Like, I can go and sign this artifact too, publish that in the transparency log, but that's not as meaningful as Pablo signing it, for example. Yeah, so that's that. And so there's a lot of like identities that are supported for signing. So Pablo uses Google when he signs the Google identity provider, but you can use Microsoft and GitHub. So the really nice thing also about OIDC is that other things can have identities, not just like email addresses. So actually every invocation of every GitHub workflow has a unique identity. So then if you sign something inside that workflow, which can be picked up, identity can be picked up automatically, you can prove like exactly what workflow ran and where that thing was signed, which is interesting. And then also like all the cloud providers support these identities as well. So the goal for signing integrity for CPython is provide a non-GPG way to verify integrity. And we did that, right? Like, that exists. There are some kind of things that we're still kind of working out there, but it essentially is done. But there's other things we want to improve upon as well. So one is Sigstore has got this notion of a verification bundle, which is essentially all the verification materials in a single file. It's a little bit easier to use. We'll have that eventually. Offline verification. So there's a way to verify that like I said, you have to check the transparency log, whether it's included in the log or not. That requires being online, being able to talk to the transparency log. So there is a way to do that offline with some additional materials, but that's like something that will happen eventually if someone wants to take all the materials somewhere else and verify them where they don't have internet access maybe. We're going to simplify some things for the release managers to make this a little bit easier. And then, yeah, just keep signing. Like, this is going to be part of the release process going forward and have these signatures. So I want to say thanks to Thomas, Lucas, and Pablo for doing some testing here and also hitting some bugs that we're going to fix. The next thing I want to talk about, so we just talked about integrity, but let's talk about actually how Python gets built. Like, back to these files. For everything here, like, where did these files come from? There's a lot of magic in this process right now, right? So the release manager cuts a source distribution, some magic happens, and then the artifacts exist on python.org. And actually there's like even more magic, right? So release manager cuts distribution, but then also somehow somewhere else, other people build artifacts for Windows and Mac OS X. And then somehow they come back and they end up on python.org. And actually even more magic, right? I don't know if you can actually see this. What actually happens is we tag release in source control in GitHub. And then a lot of magic happens. As a user, like, how do I know what's happening here? How do I verify that like the thing that got tagged actually made it all the way through this pipeline and produced what happened at the end, right? So I'd say that this is like not great, maybe some room for improvement here. We're not the worst. So I learned recently that some of the binaries for Golang are literally built inside of someone's closet in their house, like the official release binaries. So I don't think that's happening here, but I actually don't know where all the machines are that do these builds, so I could be wrong. So why is this important? So this build of these artifacts is a function over all the software that's present in the environments where the artifact is produced, even the software that doesn't necessarily need to be present. And there's lots of opportunities for compromise here, right? Reducing the size, making this easier, more transparent, means it's less likely to be compromised, easier to reason about, also easier to potentially reproduce to verify that actually the build was successful. So lots of different places where things could go wrong here, where potential for compromise exists. This diagram you might have seen before, maybe not. This is from Salsa website. So Salsa is think of it as a framework, not a like software framework, but a way to think about how secure a build pipeline is for a given artifact. And it's really just, there's levels, right? So level 0 is you do nothing. And that's basically where CPython's at right now. We don't do anything that, well, with some small exceptions, there's a couple things that we do, but nothing that will get us to essentially the first level here. And then each of these levels sort of ratchets up the requirements for the build and release process. And so level 1 starts like the thing that would take us to level 1 is if we start producing provenance. Provenance is essentially a verifiable file that describes exactly what happened to what the inputs and output was for a build process. So yeah, we're at 0 right now, and you might hear more about like provenance. That might not be a familiar word, but it's essentially a file, a format, and a standard that describes exactly what happened in the build. So my high-level goals here for CPython is to take us to fully public builds from a SHA on GitHub to a SHA, not MD5, a SHA on downloads.python.org, right? So this would be something that users could verify end-to-end and potentially even happens automatically, right? So there's a lot of like manual stuff that happens in the build right now. I know probably for the release managers, that might sound like a big, heavy lift. I think we can get a lot of support here to do this and also generate provenance for all these builds so that the actual build itself is verifiable and overall just reduce magic in the build, reduce like uncertainty and, lack of transparency in what's actually going into the build. So this would essentially take CPython to Salsa 3. Salsa 4 is not really achievable, I think, overall right now. It is possible to achieve Salsa 3 like in a very small context. I don't think this is necessarily the case, but there is a generic way to build at Salsa 3 on GitHub, and this requires like adopting certain workflows and practices. It's going to be a heavier lift to get CPython to this point, but I think it'd be really worthwhile. Some really like pie in the sky level goals here would be like full hermeticity, to sort of say that we actually can verify that nothing else has been included in the build process, and maybe even reproducibility, right? Reproducibility would be interesting if we wanted to really have a lot of faith and trust in what's actually getting built here. I'm not like full in on reproducibility because I think there's usually a lot of lift to get there and not a lot of benefit, but maybe someday. Next thing I want to talk about quickly is SBOMs. So if you haven't heard of SBOMs, you probably will start hearing about them soon. It stands for Software Bill of Materials. So this is a machine readable itemization of all the software that's in software, essentially like a turtle manifest, right? Turtles all the way down. SBOM describes this top level piece of software, everything that's below it. It's this format and a standard and potentially useful for knowing sort of what software you have running. They've been all around for a while. They're picking up in interest because of this. So essentially Log4j caused the government to have a big wake up, and Biden published an executive order in the United States on improving the nation's cybersecurity. And one of the things that it mandated, and this is just for the government's consumption of open source software, but they mandated that any software that the government consumes must publish an SBOM that describes the software that's contained within the software that they're consuming, and that the NTIA, which is the National Telecommunications Information Administration, is going to essentially decide what an SBOM is, because it was somewhat undefined. So what this means for CPython is that people will probably start asking us, CPython, to publish an SBOM for the release artifacts. That's probably not a big lift. I don't think there's a whole lot of like vendored software in CPython. The only thing that actually comes to my mind is pip and setup tools do get sort of vendored inside the releases. So that's not a big deal, right? People are going to want to see the SBOM. We should be able to generate that without any problem. The actual kind of thing that this I think is more important for CPython is that other software is going to start including CPython in its SBOM, right? And Guido was kind of talking about this at lunch yesterday, what this sort of meant when CPython was getting vendored inside of other things and CVEs are showing up in CPython and people were getting upset about those CVEs, right? So people are going to start caring a lot more about CVEs for CPython. And yeah, that's going to like, there's going to be some load as a result of that, I think. So my high level goals here, publish an SBOM for CPython. That should be fairly easy. And then also, we can't prevent CVEs, but we can potentially reduce the burden of CVEs and the way people perceive CVEs via the next thing, which is PSF as a CVE numbering authority. So CVEs are the common vulnerabilities and exposures format maintained by MITRE. And anybody can report those against any distributable software. Anybody can report those. So unless the project owners are a certificate CVE numbering authority, they have essentially no say in what can be published, and sort of any CVE can get published, and MITRE will essentially hit OK on everything. So if we become a CNA, what this means is that we would control all CVEs published for CPython, and we get to declare the score. So right now, it's sort of like the person reporting the CVE and MITRE sort of figuring out a score, and it's not necessarily maybe what we always agree with, right? So the PSF staff, so E and Chloe, I don't know if y'all know Chloe, but Chloe's a new infrastructure hire. They will be the primary CNA staff, so they'll be responsible for intaking CVE requests and triaging them and formatting the reports to MITRE and that kind of thing, with some support from the PSRT. And then also GPS, Steve and myself are going to try and participate and reduce the bus factor here, but yeah, I don't know how much I can contribute to CPython CVEs, but essentially this will make it a little bit easier for us to ensure that CVEs are meaningful for end users, right? Because this is important. We are already seeing like an uptick in reported CVEs, I'd say. Like the PSRT has seen this. People trolling old bug reports and deciding that they deserve CVEs, which stuff that's been around for 15 years maybe doesn't deserve a CVE. These like regex denial of service attacks, which are like questionable levels of impact. I think we can all understand the severity impact, but for an end user, like the CVE means bad, doesn't matter the score, doesn't matter what it is. So we can sort of adjust this a little bit. And then with this, like some new policy for the government, like if there's a CVE present, it essentially means the software cannot be used. So it can be a lot of pressure once a CVE exists for Python to ship a new release fast that someone else can then use because some CVE is not declaring it. I don't think it's the best thing, but it's sort of the state that I think the government's trending towards. So, and there will be sort of effects on all software, but specifically, I think CPython will see some effect as well. So yeah, high-level goals: reduce the burden of CVEs on the PSRT and the PSF staff and all that, and then make CVEs a little more actionable for the end user. And yeah, thanks to GPS and Steve for sort of kicking off this discussion. Thanks in advance to E and Chloe. They'll be doing a lot of the work here as well. One of the last things I want to talk about is PSF security developer in residence. So you might have heard that the OpenSSF has committed to funding this role. They have not actually funded this role. This was announced quite a while ago. This was in June. We haven't seen the check yet. It's going to happen. I work closely with the folks on the OpenSSF here, and they're very interested in it. And they've also like already funded this for OpenJS Foundation, Eclipse Foundation, other things. They're just dragging their feet basically. So why? I think CPython Dev and Res has been really successful. Like there's been a lot of benefit for CPython, for the staff, for users. This is good for the PSF too, right? Like it's really good that we've been able to demonstrate that we can like hire, fund a role, get sponsors in line to continue funding that role. And like this is a sustainable way to fund development on CPython and like potentially other things. So security is super hot right now. The security improvements, all the stuff I just mentioned, is going to only need more attention in the future. and we have like PSRT, right? And folks like me that like I don't actually work on CPython. So I think there's a demand here essentially for a similar role for security. And OpenSSF agrees, and they've agreed to fund this. So the high-level goal for this role, and this is what like publicly OpenSSF is saying, they're going to staff a head of security role for the PSF. In a similar way, this would be like a yearly contract that we would find new funders for after a while. They want to pay for a security audit. They just said security audit. So I don't know what that's an audit of. It could be PyPI, it could be anything, right? And they want like monthly updates. So kind of like Ugrashes, I think, has seen that to be successful as well. My lower level goals for this is like, I think I'd really like to see faster response times for things that are security related. So we get a lot of stuff to PSRT and security at PyPI, mostly around malware and things like that. And someone that's able to work full time in this can make those responses a little better and make those things less impactful for end users when they actually are problems. Like I mentioned before, like this would be a person that could be full-time staff to triage and issue CVEs and work with E and Chloe to do that. Actually do some of the improvements that I mentioned on the build and release process. There's a lot of stuff that could be done, a lot of low-hanging fruit around making PyPI more responsive and better at catching malware and integrating vulnerability tooling into that. That could all be in scope as well. And then like docs, like it's good to communicate with users about security issues. We have something that's pretty good here that Victor maintains. Could be a lot better. Like comms could be a lot more improved here. So someone that could work full-time on this would be really great as well. So coming soon here, hopefully actual funding. And then we also have, there'll be a blog post and a job post about this. So you'll see that soon. Thanks to Lauren, Deb, and Phyllis at the PSF for kind of slowly making sure that this lands. Okay, so here's what I need from everyone in the room. First, general support for all these efforts, right? I know I'm up here, like we're at Google, I'm Google. Google has interest here, right? I'm not gonna pretend like it doesn't. But the stuff I'm proposing is not just for the benefit of Google. It's really, all this stuff is things generally accepted by the industry right now as important improvements to make in security for software when it's being distributed. And also just like generally good for end users, right? Not just good for Google, not just good for GitHub and Microsoft and everyone else that's participating, but like actual stuff that's good for users of Python. And then, in addition to that support, like some attempt to work with me, and I will try to work with you as well to understand the current process. Like it's been a bit Byzantine to try and figure that out so far. And like Pablo and folks have already helped a lot with this, but help me understand the process, but also like all the existing constraints, right? Like if I just describe something like fully public Mac OS builds, and that sounds weird to you, and like it might not be able to happen, I want to hear about that and figure out a way that we can work around it. So yeah, that's kind of what I need from all of you. And yeah, thanks for listening. So I think, I don't know how much time we have, 20 minutes until I'm off security. So yeah, I'm happy to answer questions like online here. For folks in the room, we can turn your volume up and you can unmute and ask as well. And then, like I said, I'm around. I can talk about any of this stuff, or also, PyPI or anything else too. Barry.
So the thinking really is that we will have a single role for both PyPI security and Python security, or will they be separate roles?
Well, so the funding is for a single role, but it's for the entire PSF. So I guess it's really, they're leaving it up to us to determine where the need is, right? So if the need is like, PyPI is overwhelmed with malware, we cannot address it, like that person should be able to step up into that, and that's a security related improvement. But if the need is like, we really need to overhaul a release process for CPython, we think that's really important, that's where they can put their effort, right? So
does it still make sense to me? Like we'll probably have to rethink PSRT potentially.
Like I just imagine this person being like the most responsive person on PSRT, right? And I think the support from everyone else on there is still going to be relevant, but yeah, ideally, like they're instantly responding to these things, right? Because it's their job.
We do want it to be a little bit more project managery from the PSRT side of things, with that we'll take it and stuff. But whether that's us getting that set up, whether that's the role helping get it set up, we at least do this as someone staffed full time to do this. So it'll help us.
Yeah.
That'll especially also help with, because I think we've had some media inquiries occasionally, and
Right.
we don't have sort of an official.
Yeah. So when I reply to those, I'm like, oh, let's just see what happens if I give this reply. But it's always like, I'm is talking to a media person, they're going to not understand what I say.
Yeah.
Take it in some other context. So, yeah.
Any other questions?
I guess I have another question.
Yeah.
In your mind, do you think we can get to a place, at least with the Python builds, where we essentially automated the full release process?
Yeah, that's what I would like. And then like Pablo was just explaining to Thomas the existing process, and in my head I was like, I want to change everything about that. But like it's gonna be a long process, right? Like we're gonna do it piecemeal. But yeah, like imagine just tagging something on GitHub and then having the entire build just happen in an automated fashion, and then do the little post to python.org that's necessary to publish that, right? Like I know like that's an oversimplification. You're probably like, there's dragons in there. but yeah, imagine how like nice that would be. Like imagine you wouldn't have to tell Thomas all that stuff you just told him. You just like, yeah, you like lock down the branch and you tag it, right? So yeah, I think that's the ideal. I don't know how soon we'll get there, but yeah.
I guess my other question is, are there things that you're thinking about for authors of packages that are being uploaded to PyPI that they can do in the future that will make their lives easier as well? To say, hey, this is something that I'm standing behind.
Yeah, I mean, so basically all the stuff that we described, we're going to make available to users of PyPI. That's my current plan. So we're going to have PEPs for the salsa provenance, being able to publish that to PyPI, and then also 6-door signatures. So to give you like a little context, NPM published an RFC to do essentially the same thing for their package manager. We've been working with them my team has been working with them the whole time to figure that out. We're going to do the same thing for Python. So people will be able to publish signatures, sign things, build automatically. The other, I mean, not to stray too far into PyPI stuff, which might not be interesting, but the other really cool thing that OIDC and like identities and actions enables is that we actually have a PR that I'm about to merge that will enable people to publish directly from a GitHub action without the need for credentials, because the identity uniquely identifies the action. The user essentially says, I trust this workflow in this repository in this organization to publish to PyPI. And when we can verify the identity, they can just publish. So like no passwords, no API tokens or anything. That's super powerful. Like people just being able to publish directly, and then also like link the source to the actual artifact. Because right now in PyPI, it's kind of like a crapshoot whether the repository in the metadata is actually the repository, and there's lots of like issues with that right now. But yeah, being able to like actually say, yes, this repository is the source repository for this build, this release, something we'll be able to support really soon. But yeah.
It's one thing you have in your talk is going shot to shot. That's very important. Right now we say this git tag is a release, but a tag can be moved. So it's all you've got to go from the exact shot of the thing you get and hopefully get it up. Future, not a problem. Yeah.
Yeah. So yeah, and I think one thing I didn't really talk about is I think we will start to see people wanting to reproduce this, like people asking questions about, okay, like what actually happened? How can I like verify, you tag this thing and then it became this, like, how can I ensure that that's actually what happened? I also didn't talk about the Linux releases. I'm a little fuzzy there on like, I'm assuming those distros are consuming source distributions and doing their own builds and stuff like that. Like we're not really involved there, but we could potentially like work more closely with those distros as well. Yeah. Yeah, right, more magic.
So the focus here is more on supply chain side of things, right? Because there's also just a trust of people that can commit to a repo that they're not going to do anything nefarious or that they won't get hacked. And then, their compromise leads to some vulnerability, which is unlikely, but a possibility. And in security, all possibilities are valid, right?
Yeah. Yeah, I mean, totally valid. So one thing I didn't mention, so we just did a big push for two-factor on PyPI, which is, I think, largely successful. I know that like the Python org on GitHub does not require two-factor, but I also know that we're kind of working towards that. So like that's really good. And like, if I know GPS was handing out security keys, but like we should do that with security keys and not TOTP and authenticator apps whenever possible. But the other thing is, like, I was talking about the SALSA levels. So one of the requirements for those levels is 2-party reviews and things like that, right? So as we sort of would move to those higher levels, they do have requirements of, like, we're doing 2-party reviews and source control. Source control is public and hosted, like some stuff that we're already sort of achieving right now. So, but yeah, they don't protect against a cabal of release managers going rogue, and you can't do anything about that.
Another one.
Yeah, Aaron.
You showed an example of a SIG-Store module that people could use, and that implicitly is connecting to some service somewhere,
Yes.
presumably HTTPS or something. But I mean, what kind of points of vulnerability? It seems like that's kind of a meaningful vulnerability there. If people are using that tool to verify, wouldn't be that hard to break it.
Yeah, I mean, you can go as deep into the turtles as you want, right? But yes. So the idea is that, like, all the same protections I was talking about for CPython will be available on PyPI, and like a critical project like that would be adequately protected. So, like, it's also doing public builds, it's also publishing signatures, it's also publishing provenance. So yeah, there's a lot that I think we could still do to build trust there. But yeah, and yeah, so look, SIG-Store is a centralized service. It's something that's run by the OpenSSF and is, like, distributed across a couple organizations, right? So it is in some way a single point of failure, but there's a lot of work being done to, like, sort of scale it up. Yeah. I won't get into that, but yeah.
I think of it similar to, like, Let's Encrypt, which is basically providing a huge number, 3% of all the SSL.
Yeah.
So,
Yeah, the original motivation was essentially, like, let's encrypt for artifact signing. Yeah.
There's also a thing to consider, that the amount spent on securing that SIG-Store infrastructure covered all of the open source projects that use SIG-Store or non-open source as well.
Right.
So they could spend a lot more on securing that bit without having to worry about all the other projects as well. Because everything lifts on that. It's the same reason some security-minded people want everyone to use Gmail for mail, even though it gives Google all your information. It's because the Gmail security team is really good. So it protects you against all kinds of attacks. You don't have to worry. Yeah.
So you asked, like, what are the sort of potential evidence for compromise there? So one thing is there's a lot of trust in these third-party identity providers. So, like I said, Pablo signed the release he went through an OAuth flow for his Google account that verified his identity because he's signed up for his Google account with his python.org address. Like, PSF could run its own identity provider, and we could sign with those identities as well. It's a lot of work. Like, it's a lot of work to run an identity provider. We were talking about it for PyPI, like letting PyPI users use their PyPI identities to sign things. But the benefit's not quite there. Like, essentially for the reason that Thomas just said, like, I trust the Google accounts security team far more than any level of effort we could potentially put into our own identity provider. I actually think it's better for us to use that centralized stuff. So SIG-Store is another example of that, where, like, we could stand up our own SIG-Store instance, right? Like, it's open source and they make that possible, but we're not gonna be able to staff, like, SREs on that and make sure it stays up and all that. So yeah. Pablo.
I'm kind of interested in the process for the PSF to become a CNA, like what's required there, and also, like, how that will work in the sense that I assume there will be someone from the PSF who will organize this, but, like, for instance, let's say we have a CVE and we want to pull a number in that, like, do you have, I mean, I suppose we need to discuss that, but, like, do you have any proposal or idea or how the organization will look like? Like, who will decide the number or how we will arrive to the number?
So yeah, the process of becoming a CNA is essentially, we emailed them and they were like, yeah, duh. So some folks, that's literally what E said. So some folks like E and myself and GPS are going to sit in a short, like training, I guess.
I think we did just sit in a pre-prepared 2-hour training about some stuff they wanted to do.
I don't think it's even that long. That was about, like, becoming a root. Yeah. So yeah, there's another thing. So it's fairly simple. It's mostly about aligning the reporting process so that we correctly make reports to MITRE. But essentially, they will redirect all reports about CPython to us. So we'll have the opportunity to triage it, set the score for it, that kind of thing. As far as the picking the number, I don't think we actually get to pick the number. I think MITRE will assign it to us, but we essentially generate the report and edit it and everything.
I think supplement the C, that's.
Is that the bank?
Oh yeah, the score itself. Yes, yeah.
I'm asking because we have, for instance, some weird reports. Like if you go to the series assigned to CPython, we have reports that have a 10.
Yeah.
Because the test suite runs like HTTP repositories and runs the server.
That's exactly
And then
what you want to filter out.
yeah, it's kind of bananas. And then we have like a 5 or a 6 from the integer.
Yeah.
It's kind of like inconsistent to say the least.
So what will happen is someone will find that stuff and they will report it to MITRE or to us, and then we'll get the opportunity to say either no, this is not a vulnerability, right? We can just flat out say no, or we can change the score to be whatever we think is appropriate, right? So part of the training is sort of like setting expectations for what those scores should be, like sort of across the CVE ecosystem, making sure that ours are aligned with that, so that when we do have a 10, we actually say it's a 10. But yeah,
My question regarding the score is among us, like let's say we are already like, okay, so we have this thing, we understand what it is, like how we decide as CPython or the PSF or like both together, like who decides? Is like the PSRT team, is the Corda team?
Yeah. So E and Chloe will be the actual people writing reports, but we'll be working with, essentially that'll be PSRT. We'll have to.
Think of it as PSRT, like there's several of us going to sign up for what would be part of the CNA thing, but ultimately it's like the integer denial of service thing. Christian Knights and I talked back and forth. It's like, okay, they have an extremely well documented thing for like version 2 and version 3 scores in terms of what's what. You can come up with numbers on those and go, I really don't like the score that came out of this. And then you have to look at it and say, does that make sense? Is there context that would change this? But right now, it's just a free for all. Anyone filing CVs to say whatever they want. Thing in a test suite. Come on. Yeah.
So the other thing that GPS kind of mentioned, so there is an additional thing we can do as a CNA, which is becoming a root CNA. So for example, Google is a root CNA, and then runs sub CNAs for like Android, Chrome, like all those individual projects. So I think our plan right now is we're going to just become a CNA and only focus on CPython for now, but there is a potential for, if there are other PSF projects that are getting CVE reports, we can expand into a root CNA. That's like just a longer training, it sounds like, and issue CVEs for sub projects as well. But right now, just CPython.
Isn't becoming a CNA a conflict of interest kind of, because you are the one like are responsible for introducing a bug, and then you are the one who's saying that it is not a security.
Maybe not.
But we're also the best authority on the actual, severity of a CVE.
Given the number of junk reports we get,
Right.
I think it's an important function.
Yeah, I mean, there's a level of trust that we're going to like act in users' best interests and not downplay actual vulnerabilities and things just to make ourselves look better. But
The reason I say it's maybe not also is that, okay, we're kind of like guiding what happens to the project we're on. We're also all here representing, half the time other companies and other things who have an interest in this stuff actually being, nice, good software. So I think we actually have a great everyone studying just make a project look excellent. So yeah, I see your question though. I see your.
anybody want to be the Devin Res for security? Yeah, Cam.
Yeah, I'm just curious, I guess, kind of circling back to our previous topic. It seems like it would seem like a big point of vulnerability is the transparency log. It seems like that can be a core point of trust, that if that can be compromised, then it effectively compromises all the security of the system. And I'm curious what sort of protections are in place, given obviously there'd be a lot of resources directed for that. I can only assume, but on the other hand, if it's the core root of trust for lots and lots of projects that are important projects that are using it, it also means there's more attacker resources directed for compromising it, because there's more benefit if it is compromised. So I'm curious what sort of protections are in place there.
Yeah, so the CT log in use is very similar in terms of infrastructure to CT logs being used for browser certificates and everything else, right? The scale is not the same. My understanding is the CT logs for other transparency logs, they receive the order of like millions of events, certificate requests per day. Sigstore is not there yet. I mean, it is somewhat of a new piece of nascent technology. So scale's not the same, but the technology and infrastructure is the same, sort of built on the same specifications and protocols and everything like that. It's not like a one-off home-baked kind of CT log. That said, I think like the actual risk there is the underlying infrastructure and staff. So it doesn't have the same level of, it doesn't have an SLO and things like that right now. And in terms of response to issues and things like that, it's still sort of getting up. But what's happening is OpenSSF is owning it, getting a lot of investment from interested parties. So like GitHub is going to integrate really tightly with Sigstore via NPM and also some stuff for GitHub itself. So they are investing like staff essentially to work on this full time. So it should be a service that's at the production level of all these organizations that are depending on it and using it eventually. But yeah, I mean, there are points of failure here all along, but it's got a pretty significant investment already.
Well, and just to touch on that, you can also easily replicate the transparency logs for third-party backup as well, so that primary Sigstore copy gets optimized, can be picked up.
Yeah. I should say that there are people essentially running monitors on the log too to verify its integrity as it is, as it continues to exist. So presumably those people would all make a big deal if something actually like went wrong with the log or in terms of integrity, but we'll see. Hasn't happened yet. Cool. Well, I'm right at an hour, so I'm just going to stop here. But again, like I'm very happy to chat about all this stuff, and I'll be working on sort of improving some stuff with the existing Sigstore signing stuff for the releases today and tomorrow. But happy to chat about any of this stuff. So, thanks everybody.
Thank you. And there were no questions.
Thanks everyone online as well.
Yeah.
Catch you guys later.